In this tutorial, we're going to take a look at a test review for a trigonometry functions test. And so first of all, there's several multiple choice, most on this page and a little bit on the next too. And we were asked to name the function in the graph to the right. So we're asked to name this blue function here. And I've drawn in by hand this red one here. And notice it's the mirror image in the x-axis of the one we're asked to identify. And this function I've drawn here is the 2 cos x function. It has an amplitude of 2. See, there's an amplitude of 2 here. Amplitude of 2, so I need an amplitude of 2 here. And the period is 2 pi. So it's the normal cosine function just with an amplitude of 2. That's the only way it's transformed from the regular cos x graph. So this function is the reflection of the red one in the x-axis. So it would be negative 2 cos x. So that's why D is the correct answer for question number 1. Now, number 2, I'm going to draw right here. This would be the axis that goes through the middle of the graph. And so you can see there's an amplitude of 2 here, amplitude of 2. So a lot of these have 2s. Here's a 2, here's a 2, here's a 2. So here's a 3, so it couldn't be this one or that one either. Now there is a vertical shift of 4, so it does go up 4. So we've already said it can't be this one. And it can't be C here because there's no plus 4 in the end, so we could cross the C out. And now actually also D here. See, this one's moved up 3 instead of 4. So we can get rid of that one. So we're actually down to A or B now. So which one is it? Well, notice that there is a period of 3 pi here. So if I want to find the k value, the number like right beside the x, that's the k value for the graph, then you take the standard 2 pi and you divide it by the observed period. The observed period on this graph is actually 3 pi. You can see it's actually 3 pi long from there to there. So these pi's divide out, and that's the k value. So that's the only one with the 2/3 here. This one just has a 1x. So amplitude of 2, 2/3 is the k value, and it's up 4. So that's why A is the correct answer for question number 2. For question number 3, again, we're asked to identify a function, and it's this red one here. Now this is actually the secant graph, secant x. Secant and cosine are reciprocals. That's why I've written here secant x equals 1 over cos x. And I've drawn in a cosine graph. I extended the axis a little bit to get it to 2 pi because this graph didn't quite show it that far. So there's one period of the cosine graph. And because cosine and secant are reciprocals, you can use cos x to graph the secant function. So for example, right here, the cosine graph has a function value of 1. The cos of 0 is 1. So if this had a value of 1, 1 divided by 1 is 1. That's why the secant function also has the same function value there, because secant and cosine at that, well, where x is 0, have the same value. Now as you go along the cosine graph over here, get close to the asymptote. So for example, pi over 2 is the angle right there. Let me bring my calculator over here. Pi over 2 is 1.57. So if we took an angle just before that, maybe at 1.57 instead of 1.570796, etc., we would get the cosine of 1.57 is that value. It's very small. So if we went 1 divided by the cos of 1.57, the secant value there would be 1255, well, 0.76. So that's why the secant function goes up so high here, because the closer you get the cosine values to 0, the larger secant is going to be, because when you're dividing 1 by a number really close to 0, that becomes very large, because since that's so small, it goes into the 1 an awful lot of times. Well, it goes in 1255 times. That's why the function value for secant is so big. Just past the pi over 2 point, remember pi over 2 is this, so if I want an angle just past there, let's say 1.58, that's just past 1.5707, etc. So that's the cosine value there. Okay, so pretty small negative, really close to 0, and if we took 1 and divided it by that cosine of 1.58, number really close to 0. Notice that the cosine value is very small, negative 108.65. So that's why the secant graph is so far down here. As we come up along it here, you see the cosine value right there would be -1. And again, if that was -1, 1 divided by -1 is -1. So cosecant and secant, that's another place they have the same value at pi. See, 1 divided by the cos of pi exactly works out to -1. So secant is a value of -1 there. So that's how you can use the cosine graph to graph the secant function. Let's get rid of that. I'll bring it back in a moment here, actually. For number 4, we have this green function here. And I'm going to use the identity tan x is sine x over cos x. I've drawn the cosine graph and the sine graph both here. And again, extended it just a little bit. Maybe we'll bring that down just a little bit so it looks a little better. And so if we start here at 0, 0, see right there, well, sine is a value of 0 there. Cos is a value of 1. And maybe we'll bring the calculator back here. So if I take the sine of 0 and divide it by the cos of 0, that gives me 0, because we're actually dividing 0 by 1 to get 0. So that's why the tan is a function of 0 here. Now, if you go right in the middle here, at that angle right there, the cosine and sine graphs have the same value. So dividing two numbers the same, that's why you get a tan value of 1. It's not exact. I didn't draw it perfectly, but you can see the tan value is pretty close to 1 at that place right there. Now, if we get close to the asymptote, I'm going to do the same thing I did with the secant graph up here. If I were to take a sine value of an angle very close to that asymptote, but to the left of it slightly, remember 1.57 was just before the pi over 2, and divide it by the cosine of the same value, of course, that would be the tan value there. So that's an angle just slightly before the pi over 2 vertical asymptote here. And notice the tan function is, well, it's over 1200. So that's why the tan function gets so very steep here. The closer you get to the asymptote, the higher the tan value. And then just on the other side, if we were to take like a sine of the 1.58, for example, divided by the cos of the same angle, then the tan function is -108, almost -109. So that's why the tan function is so far down here. As we come up along here, at that place at pi, see the sine, well, the sine of pi is actually 0, and the cos is -1. So we're actually dividing 0 by -1, so we should get 0. So that's why back up here, the tan function is 0 again. And so that's how you can use the tan function or the sine function and cos functions to draw the tan function. So this is the graph of the tan function here for question number C. The only other one that looks a fair bit like it is the cotan function, but it has vertical asymptotes, has the same shape, has vertical asymptotes at different places. Because the cosine is what's in the denominator here, any place where cosine is 0 is a vertical asymptote for tan. So you see cosine is 0 here, cosine is 0 here, so vertical asymptote. Cosine would actually be 0 over here, so if we extended this cosine graph over here just a little bit, it would be 0 there again. And so that's another place you'd have a vertical asymptote for the tan. Places where the sine is, you see cotan x, has the sine on the bottom, cos on the top. So where the sine would be 0 is where the vertical asymptotes would be for the cotan function. Question number 5, you're asked, what's the phase shift for this function? I put a whole bunch of things on here. The number right here, that's the amplitude. The sign here tells you whether the reflection of the x-axis, now if it's negative, there is a reflection of the x-axis. The vertical translation of this number here, I actually forgot one here, I guess. Now, the 4 here allows you to find the period. It actually isn't the period. You actually go to pi and divide it by that number, and that will give you what the actual period is. What we're looking for actually, though, the phase shift is this. That tells you the phase shift, and excuse me, it's always the opposite sign. So if it says plus, you're actually going to the left. So that's why E is the correct answer for number 5 here. I did put 3 pi over 4 right. That would be in the opposite direction. Okay, so it's the opposite sign here. It's actually x minus the value for the phase shift. For question number 6, we're asked to solve sine x equals plus or minus a half on the interval 0 to, now this is written as a closed interval 0 to 2 pi. You might also see this sometime written like this. That means exactly the same thing. The x values are greater than or equal to 0 and less than or equal to 2 pi, so it means exactly the same as this does. And for this we actually need a copy of the unit circle, so I'm going to bring that up here. Now, the way the unit circle works is, and this is the radian one, these angles all go with points here. So if we rotate pi over 6 around, we get to that point. So that angle goes at that point. Pi over 4 is the rotation from 1, 0 around to here, so we use this point. The x-coordinate's the cosine, the sine is the y-coordinate. And there's actually a copy of this, if I scroll way down here, actually at the end of the review document, so you can find the same thing here, just a little larger. Go back up here. There we go. Just a little more. There we go. So we're looking for where sine is plus or minus a half. So we're looking for y-coordinates of a half. And so there's one right there. So the angle will be pi over 6. And we rotate all the way around to that point to find another one, and that would be the angle of 5 pi over 6. So B is actually the correct answer. So pi over 6, 5 pi over 6. It says plus or minus a half. So you look for, so you have the sine value of negative a half too, which is here at 7 pi over 6. And then all around over here, negative a half at 11 pi over 6. That's the other two solutions. So B is the correct answer for question number 6. The answers in D here is actually if you're looking for cosine. Cosine is a half at here, say at pi over 3, 2 pi over 3, pi over 3, 2 pi over 3. And then negative a half at 4 pi over 3 and 5 pi over 3. So that's all the cosines that are a half or negative a half. So D is actually the correct answers if it was cos x equals plus or minus a half. So let's get rid of that. Last multiple choice here, instantaneous rates are, and this is just the slope formula, are approximately using this when you take x2 and x1 very close together. If you take them far apart, it's called an average because it's over a larger portion of the graph, but if you take them very, very close together, you get a good approximation for an instantaneous rate. So that's why B is the correct answer for question number 7. For question number 1 in the second part here, we're asked to graph a couple of trig functions, and for each of these, make sure that you're always listing the characteristics, the amplitude, the period, the phase shift, the vertical translation, if there happens to be reflection in the x-axis as well. And so for this first one, the 5 out front here, the coefficient of the sine would be the amplitude. So the amplitude's 5. Because of the fact that it's just sine x, there's no number here like there is in B, the period would be the normal 2 pi. There is no phase shift for this one. This is what you see for a phase shift, and we'll get into that in B in a moment. The -3 means it's been shifted 3 down. And I normally do that first, so here's my 3 down line. That's the vertical shift down. And we're drawing a sine function, so I would start with putting a dot right there. Because the period is 2 pi, then it's going to end as the cycle, if it starts here, it's going to end at 2 pi and cross in the middle as well. And then halfway between the beginning and the middle, it is 1, 2, 3, 4, 5 above that. And halfway between the middle and the end, right here, it's 1, 2, 3, 4, 5 below. So you could just use those 5 points to draw that sine graph. For question B here on this page, the 6 is the amplitude, and the negative means it's also reflecting the x-axis, so it's a negative cosine graph. The period we get by taking the half and dividing it into 2 pi. So 2 pi divided by half is the same as 2 pi times the reciprocal of a half, which is 2. If you want to put 2 over 1 here, you can to see the full reciprocal, but you don't really need to put the 1 there. 2 pi times 2 is 4 pi. 4 pi over 1 is still 4 pi. The phase shift is pi over 2, and if it says x minus pi over 2, it's pi over 2 to the right. Remember, opposite sign of this, it's actually x minus whatever the phase shift is. The plus 2 is the vertical translation. It goes up 2. So there's the plus 2 right there. It goes up 2. And so we're drawing a negative cosine graph. So if I were starting to draw this, after I do the vertical translation 2 up, this line right across here, I would start next with, okay, it's a negative cosine graph. So I would normally start with, I'm going to go 6 below there, but because we're phase shifted pi over 2 to the right, I would take that point and move it to the right there. So there's my starting point right there. And the period is 4 pi long. So I'm going to go 4 pi over here, and that cycle is going to end at that place right there. You can count the 4 pi's. I actually have 6 blocks here as a pi. So if you want to count, well, that's 6, 12, 18, 24 to there. So it'd actually be 24 blocks from there all the way over to there. So that's where a cycle starts and ends. Halfway in the middle, which would be right here at the 2.5 pi. Remember, the cycle is 4 pi long, and we've shifted to the right pi over 2, or half a pi. So at 2.5 pi, we'll actually be 1, 2, 3, 4, 5, 6 above. So there's the maximum point. Halfway between here and here, that's where it crosses the horizontal axis in the middle. So we would put a point there and a point there, and then we could draw our cosine shape. Okay, so that's what it would look like. For question number 2 here, we have an alien ship that hovers 2,000 meters above a flat plane, and it directs a laser weapon on the plane, sweeping along the ground. So it's sweeping in this direction here. D represents the distance from wherever it's cutting to that point directly below the ship. So this would actually be a right angle right here. So we're asked to determine a reciprocal trigonometric equation that relates the 2,000 meters, the d, and the theta. So it'd be a good idea to, in terms of the angle here, and the angle is the angle between the altitude or vertical here and the beam itself. So in terms of that angle, this would be the hypotenuse, which we don't need. This would be the adjacent side, and the d would be the opposite side. So the trig ratio cotan is adjacent over opposite. Remember, tan is opposite over adjacent. So the reciprocal one, cotan, is adjacent over opposite. So it would be 2,000 over d. So that's why the cotan theta would be 2,000 over d. The 2,000 is the adjacent side, the d is the opposite side. And if we want to solve that for d, because in b here we're asked to find the exact value of d, so if we were to rearrange this for d, then I would multiply both sides by d, so that the d's divide out here. And so I would have d cotan theta equals to 2,000. And then I would divide out, to isolate the d, I would divide out the cotan theta. Right like that. And that's a theta. So those divide out, and that's where we get d is 2,000 over cotan theta. So that's a relationship that relates d and the cotan of the angle. The angle. In b here, we're asked to find the exact value of d when the angle is pi over 3. So the unit circle, and I'm going to scroll back down here again. For pi over 3, the cosine's a half, and the sine is root 3 over 2. Okay, so cosine's a half. Let me write this out. So cos pi over 3 equals a half, and the sine of pi over 3 is the root 3 over 2. The only reason I'm writing them out like that is so that I can just copy them and go back up to the question, and we can paste them. Okay, so that's the two values that we read off the unit circle. So in order to find the exact value for d, cotan is the same as cos over sine. And so I have my 2000 divided by this rational expression, so I change the division into multiplying by the reciprocal. So cos over sine becomes sine over cos, that's the reciprocal. And so d is 2000 sine theta over cos theta. So this is what I need these for. The sine of pi over 3 is root 3 over 2. So in place of the sine of pi over 3, I'll put root 3 over 2. Cosine of pi over 3 is a half, so in place of the cosine of pi over 3, we'll put 1/2 in the denominator. Those 2's divide out, so then we're left with 2000 times root 3 over 1, which is just 2000 root 3 meters. And for C here, and I put the screenshot here, but I can do this on my calculator again. Turn it on here. So the it's just 2000 multiplied by the root of 3. And that's where we get 3464.1. Now, if you have a different calculator, you might have to go times the square root of 3. Just depends on how your calculator is programmed. So that is to one decimal place, 3464.1 meters, what the length of that distance would be. So this would be 3464.1. In number 3 here, asked to solve each of the following on the interval 0 to 2 pi, kind of like that multiple choice question earlier, the second last one. And give the answer in exact form in radians, and wherever possible to two decimal places in radians. The ones that you can't get exact are the ones that aren't on the unit circle. So when you're not seeing a half, root 3 over 2, root 2 over 2, those kinds of things, -1, 0, 1, etc. So the first one is cos x minus root 2 over 2 equals 0. So the first thing I would do is I want to isolate the cos x. So cos x would equal root 2 over 2. Bring this over, or change the sign, or if you we're going to add root 2 over 2 to both sides. That's the way you learned it. 2 over 2. So those cancel out. And so that's how we get cos x equals root 2 over 2. So on the unit circle, we're looking for where, and I'm going to bring another unit circle here. So there's a unit circle. So we're looking for the cosine is positive root 2 over 2. Remember, cosine is the x coordinate. So positive root 2 over 2 here. So that's at an angle of pi over 4. And positive root 2 over 2 here, which is the angle of 7 pi over 4. So pi over 4 and 7 pi over 4 are the two solutions for A here. Now we'll need that again. For B, sine squared x minus a half equals 0. So we rearrange and get the sine squared x alone. So sine squared x would equal a half. And then we take the square root of both sides. So don't forget there's a plus or minus here. So the square root of a half, you can think of it as the root of 1 over the root of 2. We're taking the square root of both the numerator and the denominator. Now the square root of 1 is 1. So we get 1 over root 2, and you might not see 1 over root 2 on this unit circle. Well, you don't actually. But if you multiply, and this process to go from here to here is called rationalizing the denominator. So we multiply the 1 over root 2 top and bottom by the radical that's in the bottom. That's why I'm multiplying by root 2. See, this is actually 1 we're multiplying it by, so we don't actually change the value of it, we just change its form. It looks different, but it has the same value. So in the numerator, 1 times root 2 is root 2, and root 2 times root 2 is root of 4, which is the number 2. Root 2 times root 2 is 2. So that's why, see, there's root 2 over 2's here, not 1 over root 2's. 1 over root 2 and root 2 over 2 are the same thing. So we're looking for where the sine function is positive or negative root 2 over 2. Remember, sine is the y-coordinate. So there's a place right there at an angle of pi over 4. So pi over 4 is the solution. Rotate over here into the second quadrant. See, sine is root 2 over 2 here, which would be this angle. So the 3 pi over 4. Those are the two positive solutions. So down in the third quadrant down here, sine is negative root 2 over 2 at an angle of 5 pi over 4. And 7 pi over 4 is the other one over here, negative root 2 over 2 again for an angle of 7 pi over 4. For question C, and I scroll up to I pause for a moment, this was actually, if you go back in the video for a moment, it was actually down here for some reason, not sure why, but this actually goes with C up here. And so in C, you're asked to solve the equation secant squared x plus secant x minus 6 equals 0. And this is a quadratic type equation. I want to factor this, and it's really the same kind of factoring as if you were factoring x squared plus x minus 6 equals 0. Okay, but instead of x, we've actually got a secant x. So we want to find two numbers that add to 1. So add to positive 1 and multiply to the negative 6. And that would be 3 and negative 2. So now, so if I were factoring this, my factors would be x plus 3 and x minus 2. But it's not just x here, it's actually secant x. So that's why the factors would be secant x plus 3 and secant x minus 2. So that's how this factors. So we set each of these to 0. So if we set secant x plus 3 equal to 0, we would get secant x equals negative 3. And if we set secant x minus 2 equal to 0 and solve for secant x would equal positive 2. So on the unit circle, and here's our unit circle, you only see cosines and sines, so we have to change this back into cosines or sines. Secant is a reciprocal of cosine, so that's why I'll use cosine. If secant x equals negative 3, then cos x is the reciprocal of that, negative 1/3. Same with over here, secant x equals 2, so cos x would be 1 over 2 or a half. Now the cosine of there are values of a half on here. So where's cosine a half? Oh, there's one there at pi over 3. So that's what pi over 3 is the solution. And 5 pi over 3 is the other one, because down here, see, cosine's also a half there. So 5 pi over 3 is the other solution. You don't see a negative 1/3 in here anywhere, so that's why we would use the graphing calculator. So I'll bring it over. I have the screenshot here anyway, but of course, make sure your calculator's in radian mode. So inverse cosine of negative 1/3, negative 1 divided by 3. So that's where that 1.9106 number comes from. Now, so that actually means that, see, cosine is negative in these two quadrants. So we'd have an angle over here that the cosine value is negative 1/3. And then there'd be another solution down here. The relationship between those two angles is, if I know the angle in the third quadrant, it would look something like this. So the angle, it's actually hard to write on here. Yeah. The angle would be something like this. And then the 1.91 radians is the rotation around to here. There would be another angle reflected in the y-axis like this. And so if this is 1.91 radians, then this angle right here would be the same size, 1.91 radians. But I would always want to know, and I can't draw in there, that's the difficult thing here. I would always want to know, you see, that is 1.91 radians, but what I want to know for this last one is, see, the rotation around to there. So, you see, this is negative 1.91. So to get that last one, I would take 2 pi, a full revolution, and I want to take away the 1.91. So that's why my calculation here is 2 pi minus that 1.91. So the rotation around to there is, that's where we get the 4.37 radians from. And that would be the other solution. So there's actually 2 for each of these factors. For question D, 3 cosecant squared x plus 2 cosecant x minus 8 equals 0. More quadratic type factoring. I want to find two numbers that add to that 2 from the middle cosecant, and that multiply to 3 times negative 8 is negative 24. And so those numbers would be 6 and negative 4. So this is actually factoring by decomposition here. I'm decomposing the 2x squared, 2 cosecant x into 6 cosecant x minus 4 cosecant x. It doesn't matter what you put first. I put the 6 cosecant x first. In these two, the common factor would be a 3 cosecant x that we can factor out. And so we factor 3 cosecant x out of this, we're just left with a cosecant x, and divide that by 3 cosecant x, we get plus 2. You can factor a negative 4 out of these, so again we get a cosecant x plus 2, and that can be common factored out. 3 cosecant x minus 4 is the other. So we set each to 0. If we set this one to 0, we get negative 2, cosecant x equals negative 2. And if we set the 3 cosecant x minus 4 equal to 0 and solve. So bring the 4 over, so 3 cosecant x would equal 4, and then we divide out the 3. They're gone. So that's where we get cosecant x equals 4/3. Now, the reciprocal of cosecant is sine. So I'm going to bring my unit circle back down here. So cosecant x equals negative 2 would change into sine x equals negative 1/2. We'll bring it down just a little more. Actually, maybe we'll get rid of this. There we go. So we're looking for where sine is negative 1/2, and negative 1/2 is on the unit circle. Where's sine negative 1/2? Actually, sine is positive in these two quadrants, so you'd have to look down here. Sine is negative 1/2 here, which is the 7 pi over 6 angle, and also over here at the 11 pi over 6. So that's why 7 pi over 6 and 11 pi over 6 are the two exact solutions. And then, where's sine positive 3/4? Again, sine is positive in these two. So we would take our calculator, and so inverse sine of 3/4, you could just type in 0.752. And so we get 0.84806 radians. Now, that's actually the solution in the first quadrant, which would kind of look something like this. And then if we reflect that over here, there's going to be another solution over here. So this rotation, whoops, I meant to draw there. This rotation around to here would be the 0.848 radians. But we want to know for the second one what the rotation is around to here. Now you see this rotation here would be the same as this 0.848 radians. So if I want to know this one around to here, it's actually pi minus that bit. So if we take our calculator and go pi minus that 0.848, that's where we get 2.2935. Okay, so that's where the last solution from the sine x equals 3/4 would come from. Question number 4 here. The height of a Ferris wheel rider above the ground can be modeled by the function h of t equals negative 20 cos pi over 15t plus 21. So h of t is the height of the rider in meters, and t is the time in seconds. And we're only considering this for times between 0 and 240 seconds. So it says consider a ride when t equals 0 represents 2 p.m. when that's when the ride starts. We're asked to find the first 3 times when the height is 30 meters above the ground. So when the height is 30, so we put 30 in place of h of t and solve for time. So I did that, and so I rearranged. I brought this cosine term over here, so it's positive 20 cos pi over 15t. And so I would bring the 30 over here and subtract from the 21 to get negative 9. Now, I next divided both sides by 20. So that divides out. So that's why I have negative 9 over 20 on the right over here. And the way you get rid of the cosine is you do the opposite of taking the cos of a value. You take the inverse cos. So pi over 15t would be the inverse cos of this negative 9 over 20. And then I want to solve for time. See, I have the pi over 15t here alone. So I would get rid of the pi over 15 by multiplying both sides by 15 over pi, by the reciprocal of the pi over 15. So, and of course we do the same thing on this side, so 15 over pi. So these divide out, same with the 15s. And so that's why we have just t on the left equals, and that's exactly what's down here. So, on our calculator, we would go bracket 15 over pi times the inverse cos of negative 9 over 20. Negative 9 over 20. And so 9.73 approximately is the first time. Where are the other ones? Well, if you want to know the period, the length of a full cycle here, you use the pi over 15. So take 2 pi and divide it by the pi over 15. So we would do 2 pi then and multiply by the reciprocal of this, which would be 15 over pi. The pi's divide out, and 2 times 15 gives us 30 seconds. I'm going to scroll up here just a little bit. So this is what the graph looks like. See, that 9.73 is the first time. This line here is actually at 30 seconds. 30 meters. So that's the 9.73. So if this would be a full cycle from there to there, that would be 30 seconds. Okay, not to be confused with this 30 here. So that's 30 seconds there. So if I want to find the next time here, this one here, see, that took 9.73. So from here down to the end would be another 9.73. So if you take 30 and subtract the 9.73, you'll get how much the time is from here to that point, because it'd be, that's 9.73. It's 9.73 seconds before the end of the first cycle, before the 30 seconds is elapsed. So 20.27 gives us that one. And if we want to get to the third one, which is the next one right here, see, this would be 30 seconds and another 9.73. So that's why I would take 30 and add 9.73 to get the third one, 39.37 seconds. And of course, they're all after 2 p.m. So if you wanted to write them in order, it would be 2 and let's see now, 9 seconds. So it'd be 2 minutes. And then we need to do 7.3 seconds. So that's the first one. And then 2 p.m. and 20.27. So we'd have to write them like that because they're just, well, seconds after the 2 p.m. Not even a minute after the 2 p.m., the first few here. And these graphs do show the first 3 of them. So question number 5 says, explain what the 0 to 240 represents in question 4 and why there is more than one time when the height's 30. So this means we're considering the a length of a ride of 240 seconds. So 0 to 240. And there's quite a few because, see, the period's only 30 seconds long. So in the length of a ride is 30 seconds long, but we're going for a total ride of 240. So if you divide 240 by 30, you actually get 8. So actually there's 8 revolutions, full revolutions, like you go around the Ferris wheel 8 times. So there's lots of times when you're going to be 30 meters off the ground. So you start here, and after 9.73 seconds, you're at 30 meters, and you go up to the top, and then you hit it again on the way down. Go down to the bottom. Okay, on the way up, next ride, another time, and the second cycle, up again, on the way down, another 30. So there's lots of them. So there's quite a few times when you would be 30 meters off the ground. Number 6 here, the following table shows for 14 days the number of views a certain YouTube channel experiences. And so you're asked to graph it and then write a sine or cosine equation to model the data. So I graphed all the points here, and it does look fairly cyclic. It's not a perfect sine or cosine graph, but it's reasonably close. And so in order to model this, we want to identify the amplitude, period, phase shift, vertical translation, etc. for the function. So to get the amplitude is half the distance from a highest point to a lowest point. So I said that the highest points were, now I'm doing this, I'm just estimating. The highest points are around 2200. Now this one doesn't quite go to 2200, but these are getting pretty close. So I did 2200 minus, and the lowest are around 1300. So you see that one there, the first one was 1365. There's a couple more here that are a little over 1300. So I'm just rounding again. So the distance from here to here, 2200 minus 1300, and then divided by 2, because the amplitude is half that distance from the top to the bottom. And so 2200 minus 1300 is 900, divided by 2 is 450. So the amplitude is about 450. If that's one cycle and that's another cycle, there's 2 full cycles in the 14 days. So it looks like the period is 7 days. The phase shift. Depends on whether you're using sine or cosine. So on the graph, I'm going to put the horizontal line, the axis that goes through, something like that. And the vertical, that's actually the vertical translation. So it would be the average between the 2200 at the top and 1300 at the bottom. So if we add 2200 and 1300, bring our handy-dandy scientific calculator back again. 2200 plus the 1300 at the bottom, add them, divide by 2. It's around 1750. So 1750, just below the 1800, is approximately where the axis is in the middle. So this height should be about the same as this. So that's the vertical translation. Now back to the phase shift. It depends on whether you want to use sine or cosine. You see sine, you want to go to the middle. So it looks like the sine graph in the middle would be around there. Okay, so that's about in the middle between 0 and 5 days. So 2.5 days, 3 days. Again, we're just approximating here. And for the cosine, you're going from the beginning to a peak. So it's just before the 5, so 4 days, maybe slightly more, but the phase shift for the cosine would be around 4. So some possible equations are, if I did the sine, so it'd be 450 at the beginning for both, and if I'm doing the sine, then it's 2 pi over 7, where it's 2 pi divided by the actual period, d minus 2.5 days, because it's 2.5 days to the right, plus the 1750. For the cosine graph, very similar. Okay, the only difference is the phase shift. Okay, it's 4 days to the right, so instead of being d minus 2.5, it'd be d minus 4. Okay, because it's a different phase shift. So that's 2 possible equations for this data. For question number 7, the height above the ground of a child in a swing is modeled by this equation. H of t is equal to 0.3 sine pi over 0.6 t plus 0.5. H of t is the distance above the ground in meters, and t is the time in seconds after the child began swinging. So we're asked to find a good approximation for the instantaneous velocity at 1.85 seconds. So I would take my time of 1.85 and another time really close to it, just before or just after. I used 1.86 seconds, so just after. So this would be the change in height and this is the change in time. Change in height divided by change in time will be the rate. And they're really close times. That's why we would call it an instantaneous rate, or a good approximation for an instantaneous rate. So h of 1.86, I would put 1.86 in place of time here, and then minus h of 1.85 in place of time here. These 0.5s are going to add to 0, because when I take the brackets off, this would be minus 0.5, so I have 0.5 minus 0.5. So those are actually gone. That's why you don't see them on the next line. So basically it's 0.3 times this sign minus 0.3 times this sign. And of course the 2 times subtract to 0.01 seconds, 1/100th of a second. The graph and calculated image looks like this. So we get a rate of, that's the actual calculation, negative 1.5 meters per second. Fairly slow speed, which means that the rate is decreasing. Okay, they'd actually just passed a bottom and slowing down as they started to rise toward the next highest point. So that would be the instantaneous rate at 1.85 seconds. And that's the end of the video.